Hello and welcome to Dice Problems. Today you're going to be tasked with 4 problems and to decide in each of these problems if the events are mutually exclusive, be able to explain why they are or why they're not, and then to prove if they are independent. Remember, we have 3 formulas that prove independence, and you can use any of these, at least for the first problem. And so what I want you to do is, answering these 2 questions, I want you to consider 2 events. The first event is the event that we roll 2 dice and we get doubles. The second event is that we roll 2 dice and that the sum of the dice is 8. So using these 2 events, I would like you to answer, are A and B mutually exclusive? Prove it. Are A and B independent? Prove it using one of the formulas. Okay? Pause the video now and go. Okay, here's the answer once you paused it and worked it out as a group. Alright, the first thing is, are they mutually exclusive? Well, really the question, remember, that we're trying to answer is there an overlap? Is it like this or is it like this? This one is mutually exclusive, this one is not mutually exclusive. Is it possible to roll doubles that also add up to be 8? Well, the roll for 4 is a roll that's both of those, so that one roll is going to be the overlap. So we would say not mutually exclusive because of that roll in the overlap. And now if we want to prove independence, I will take the first formula. I'll take probability of A and B, and I'm going to see if that's equal to the probability of A times probability of B. Okay, A and B, we're looking at what are the rolls that are both doubles and also add up to be 8. And so the only roll that does that is 4, so there's one roll out of 36. The probability of rolling doubles, there are 6 rolls, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So that's 6 out of the 36. And the probability that the dice total 8, let's see, we've got 6, 2, 2, 6, 3, 5, 5, 3, and 4, 4. 5 total rolls out of the 36. So I'm going to grab my calculator and simply punch this up and see if it is equal. 1 out of 36 is 0.0277. 6 divided by 36, 0.1666. 5 out of 36 is 0.1388. And now if I multiply those together, I get 0.023, and this is 0.027, so those are not equal. If they're not equal, then the independent formula does not work, so therefore it is not independent. And this is why. Okay? Next problem. Let's change this. We're going to make this 7 for problem number 2. And I'm going to tell you that you're not allowed to use this formula. You have to use one of these 2 formulas for this next problem. Pause the video, work it out. I'll erase this and get ready to explain. Pause. Okay, problem number 2. A and B. Is there an overlap? Well, let's think about the rolls that we have as possibilities. The doubles are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. The ones that sum up to be 7 are 6, 1, 1, 6, 5, 2, 2, 5, 3, 4, and 4, 3. So 6 of these rolls, 6 of these rolls. The question now is, are there any that are in both groups? Any that are both doubles and also add up to be 7? No, there are not. So that is this picture. We would say that these events are mutually exclusive because they cannot both happen at the same time. Now we want to consider independence. Probability of A. Probability of A given B. Well, this one is easy. There are 6 rolls that are doubles, so there's 6 out of the 36 rolls. And this one, the way to think about it is it's A given B. So doubles given that the sum is 7. So we're looking at this first. If we know this happens, that means it's one of these rolls. There are 6 possible rolls here. What's the probability? Are any of these doubles? What's the probability of being doubles if this has already happened? There are 6 rolls here, but none of them are doubles. So you have a probability of 0. And 0 does not equal this, so therefore these are not independent. Okay? Problem number 3, we're going to change this event, and we're going to say, all right, this event here, we'll keep this as 7. We're going to say now, event A is going to be, let's suppose we roll 2 dice, one of them's green, one of them's white. Event A is going to be the probability that the green die that we roll is 1. Okay? Pause the video, answer the same 2 questions with these 2 events. Go. And play. Okay. Are they mutually exclusive? Well, let's first consider what my possible rolls are. If I have a green and a white, I could have 1, 1. I could have 1, 2. I could have 1, 3, 1, 4, 1, 5, or 1, 6. Those are the possible rolls where green is 1. And there are 6 of those rolls, right? Do any of these rolls add up to be 7? Let's consider the 7s, right? We have, again, 6, 1, 1, 6, 2, 5, 5, 2, 3, 4, and 4, 3. Are any of these rolls also one of these rolls? Aha, this one right here is the same. So there is an overlap, so they are not mutually exclusive. Are they independent? Well, what's the probability of A here? Let's do this one. Probability of event A, there are 6 rolls out of the 36. Probability of A given B now is saying if we know this has happened, if the sum of the dice is 7, so it's one of these 6 rolls, what's the probability that the green is 1? And it looks like it'd be this 1, 6. This is the only one where the green die is 1. So there's a 1 out of 6 chance. Hey, this reduces to be 1/6 equals 1/6. So that proves that they are independent. So they are independent and they are not mutually exclusive. Okay? Problem number 4. We're going to keep this green die as 1, but we're going to change event B. Let's say event B is the event that we get doubles. Okay, pause the video. Try problem number 4. Answer both of these questions. Go. Okay, and start. I'm going to keep this up. These are the 6 rolls where the green die is 1. And I'm also now looking for my doubles. My doubles possibilities are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So, is there an overlap? Are there any of these that are also these? Well, this one, the 1, 1. So again, there's one roll where there's an overlap, so they are not mutually exclusive. For independence, let's try this again. Probability of A, we know is this, is going to be 6 out of 36. Probability of A given B means if B has happened and it's one of these double rolls, there are 6 of those possibilities. What's the probability of the green die being 1? Well, it looks like this is the only roll where the green die is 1. So there is 1/6 chance. So once again, this reduces and it's equal. So they are indeed independent.